Okay, so we have an integer variable here, and it's set to 2,147,483,647. And if we click this button to add 1 to it, now it turns negative. And even if we try to change this number manually, Rec Room will refuse to do it. Why does this happen? Well, allow me to introduce you to binary.
Bender, what is it?
Oh, what an awful dream! Ones and zeros everywhere!
Now, every modern computer we have communicates in binary, which is just a long series of ones and zeros. We actually have chips for binary in Rec Room, but I'm not 100% sure how to use them or what exactly to use them for. Maybe you guys can tell me. Okay, it was at this point in writing the script where I felt like I needed to learn a little bit more and do some circuits. So I went in and I made a circuit that changes binary into integers, but I also made one that changes integers into binary. And you can get them on the Invention Store, they're free. Also use code RCL1 or hit that support button on my page. Okay, so back to why this happens. Rec Room, and therefore Unity, specifically uses a series of 32 ones and zeros for integers. So the way you convert from binary into integers. Label each position of your binary number starting from 0, 1, 2, 3, and on. Take the number 2, raise it by that position number, and whatever that result is, multiply it by what your actual bit number is. You take all of the resulting numbers and add them together. We're going to do an example here to help. So imagine we have the binary number 1010. Let's convert that into an integer. Well, we start off by labeling our positions. The first one is 0, then we have 1, 2, 3. All of those, we're gonna go 2 raised to the position number. Then we're gonna multiply those by if it's a 1 or a 0. So this one we get 0, then we get 2, then we get 0 again, then we get 8. And then we just add up the ones at the end and we end up with 10. With that example, hopefully you have a little bit more idea how that works. If we take these position numbers and go all the way out to 32, since there's 32 ones and zeros, that number gets pretty big. It actually becomes 4,294,967,000. This is the highest number that we can make with 32 bits. But wait, didn't we say that 2 billion and whatever was the highest from earlier? Well, it actually only uses 31 because that very first 1 or 0 is actually used to code the positive or negative sign. So removing that 1 or 0 for the positive or negative, we're left with 31, ones and zeros to use for the number, raise 2 by 31, and we get our magic 2 billion and whatever number. And this also explains how once we added 1, it flipped over to negative. But now what can we do with this knowledge? How can we break Rec Room? Should we break Rec Room with this? So the first thing that I thought that came to mind was using it to break Rec Room currency. I don't know what advantage you would get by ending up with negative currency, but I figure we test it anyway. You can only give 1 billion tokens or whatever currency you have in your room in a given day. So I thought this is pretty easy. All I've got to do is give myself 1 billion this day, give myself 1 billion a second day, and then give myself 1 billion a third day, and we'll see if it breaks. We ran into an interesting result. Hello everyone, Editing RCL here. I feel like I did a bad job of explaining exactly what happened. Basically, I gave myself 1 billion in-game currency on that first day, and then I came back the second day to give myself 1 billion more, and it wouldn't give it to me. And then I came back a third day to try it, and it also wouldn't give it to me. It just maxed out at 1 billion. 1 billion isn't just a daily limit. It's the actual top limit. You're only allowed to have 1 billion whatever in-room currency. I don't really know what else we can do to break Rec Room. You can break individual games if you end up at like 2 billion and something in your actual games. But how often is that going to happen? How else do you think you could break Rec Room using this limit that you now know?